Okay, so this lesson 6 of unit 13 is about vertical shifts. So we're talking about y, changes in y, or your b value for um, linear equations, and then your k value for anything else really. Okay, so here are two graphs. You have f sub x, is this one right here, and then you have this dotted one, which is g sub x. That's what the dotted line is, g sub x. Okay, and how did it shift? Right, if you look here, let me make the dot a little bigger. My original vertex on this parabola was at 0, 0, and it shifted down. The x value stayed the same, but the y value is now -4. So the change in y was -4. Okay, so the good thing about these shifts as compared to your horizontal shifts is they're more intuitive. You just have to do what is happening mathematically in the equation, and the same thing is happening on the graph. Whereas in for vertical shifts, what it's doing on the graph, you have to do opposite mathematically or algebraically in the equation. So describe how that shifted coincides with the g sub x. Right, every point on here shifted down it shifted down by subtracting 4 from each point, right, from the y direction, in the y direction. Okay, so it moved down 4 units, moved down 4 units. Okay, so right here we have f sub x, and you notice that here these values, the change is 0, no change in x. And if we look at here, when it's x is -1, y is 1. When x is 0, y is 0. And when x is 1, y is 1. Right, for this one up here. Right, and that should have been blue, but that's okay. Right, so now if I want to shift from this to this, I'm shifting 4 down. So this should be at -3. All right, this one would be at -4. And this one will be at -3. The x values are the same, but the y values have shifted down now. Okay, and then mathematically, it's going to be g sub x equals f sub x, then -4. Right, it's not inside the parentheses. Remember what we do when things are inside the parentheses, you change the sign. When it's outside the parentheses, you don't change the sign. Okay, so this is a vertical shift of x. Right, we have to subtract 4 from each y value and for each corresponding x value, meaning that the x values stay the same, but the y values changed by 4 in that negative direction. Okay, so here is a complete the statement that best describes what's going on here. Okay, we have the graph g sub x is f sub x plus 7, right? And then how that compares to f sub x minus equal the graph x sub x minus 1. Okay, so or the absolute value of x minus 1. All right, so complete statements to describe how the graph f sub x or g sub x equals f sub x plus 7 compares to f sub x minus the absolute value of x minus 1. Okay, well, I think this is a typo. G sub x is a vertical shift of f sub x. Yeah, this has got to be a typo. Let me pause this for a second and read it more clearly. Okay, I guess what this is saying. All right, so this is saying, hey, g sub x is this function, which is f sub x plus 7. Okay, so this is saying like g sub x. I'm just going to do a real quick substitution right here. Substitute this in for that. So g sub x equals the absolute value of x minus 1 plus 7, right? So this is a vertical shift. Oh, I'm writing on the wrong one. Whoops. Right, so you can substitute this in for this, right? So I will get something like g sub x equals this, the absolute value of x minus 1 plus 7. Okay, so this is going to be a vertical shift. G sub x is a vertical shift of x. It's going to go shift 7 units up. Going to shift 7 units up from f sub x, the initial one. So this is just x minus 1 plus 7, right? So x minus 1 looked like this. The vertex is like that, right? I'm going to shift this up 7, and it's just going to look like this, right? But this is at 7, and that's at 0, right? Because this one is plus or minus 0. Okay, so let's see what else is saying. Describe how the effects of b sub x. So this is pretty simple, right? So c sub x is going to be equal to the absolute value of x plus 5 minus 7. So this is a downward shift, right? Or so c sub x is 7 below, or I guess I can just put 7 below f sub x. All right, or you could say that, and this is, we'll say, or b sub x, b sub x. So we'll say b sub x looks like this. Let me put down b sub x, here's the coordinate plane, right? And b sub x looks something like, okay, this is b sub x, right? And it's going to be x plus 5, so it's going to be at 1, just like going to be like this, something like that, okay? And but if I subtract 7 from this to get c sub x, it's just b sub x minus 7, so it'll look like this. Or these are the same values of x, but this is negative 7, okay, for every point on there. All right, so that's how that works. Okay, so described how p sub x is 4/5 x plus 2, right? And then, so let's kind of sketch this real quick. So we're going to have p sub x, is this red one, right? Let's make it a little bit thinner. So this is going to be, it starts at positive 2, right? Positive 2, and it's going to go up 4, 1, 2, 3, 4, and over 5. It's going to be like that, something like this, okay? With a positive slope of a change in 4y for every change in 5x. Now, if I take this and I add 8 to it, find r sub x. So r sub x equals p sub x, which is this thing, equals p sub x. P sub x is 4/5 x plus 2, right? And then the rest of r sub x, so we're adding 8 to it, right? So this is combined to make r sub x equals 4/5 x plus 10, right? So it's going to be at plus 10 now, but it's going to have the same slope with parallel lines. And you may remember, in order to shift up or down a parallel line, all you got to do is change the y-intercept for a linear function. So those are pretty straightforward. Okay, and here's the same thing. We'll have an x and a y, x and a y, right? And m sub x is n of x plus 10, okay? So our initial function, we'll draw in red, is right here, n sub x, right? And it's x squared plus 3, right? So our x squared, this is a parabola, right? And this is x plus 0 squared, right? So the y, the x-intercept, or the x value of the vertex is at 0, and then the y value of the vertex is at positive 3, right here. So it looks like this. Okay. Now it's saying that m sub x is n sub x plus 10. All right. So how does this whole thing work? So you remember from the last unit that if I have the thing inside parentheses, is I'm adding 10 to x, right? I'm adding 10 to the x term in here, right? So this is n sub x plus 10, right? So this is n sub x plus 10, right? So what happens when I add a plus sign, when I add something to the x term? Well, it shifts everything to the left. So it subtracts it because it's inside parentheses. Now this n sub x, right, is x squared plus 3, but the x is added 10 to it, right? So this is, the plus 3 is a component of this n sub x. So I'm just going to shift this thing over 10, right? And it's going to look like this, right? And the delta between any point on there is 10. Right, the delta x is 10, right? So that is saying, so that this is saying that m sub x is to the left of n sub x by 10 units. Okay, so that one's not as intuitive, again, because I'm shifting it to the left. And you remember that plus 3 is part of that n sub x. Right? I added plus 10, shifting it over to the left. Okay, so hopefully that makes sense. This one is, you're probably going to need some practice with that one, because it is a little confusing because that 3 just kind of seems like it disappears. Remember, that 3 is part of n sub x. Okay, so hopefully that makes some sense. And if you didn't get it, watch the video that preceded these other two videos.